Okay. Bismillahirrahmanirrahim. So we'll formally begin today's webinar. I would like to invite all the participants for today's webinar on machine learning and data-driven policymaking for sustainable urban development. Today's webinar will be delivered by Dr. Zubair Khalid, who is Associate Professor of Electrical Engineering at LUMS University, Pakistan. I will briefly explain the format of today's webinar. It will be a 1-hour lecture by Dr. Zubair. Afterwards, we can have questions from the participants. So after the lecture, just mention your questions in the chat and we'll take the questions then. To begin, I would like to request Mr. Haris, Program Manager at Comstech, to briefly introduce the speaker before we move on to the lecture. Over to you, Haris.
Thank you, Hasib. On behalf of Comstech, I welcome all the participants and our guest speaker for today. Dr. Zubair is an associate professor in the electrical engineering department at LUMS. He did his PhD from the Australian National University and his bachelor's from the University of Technology, UET Lahore. His research interests include the use of machine learning, data processing, computer vision, natural language processing, and other applications. He has over 75 publications in international journals, and he's also a senior member of IEEE. So I would request Dr. Zubair for his lecture for today.
Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Thank you, Haris, for such a kind introduction. Let me share my slides. I assume my slides are visible.
Yes, sir, they are.
Thank you very much. First of all, I would like to thank you, Comstech team, for organizing this webinar and giving me an opportunity to present our work, which is we're trying to do to save our cities using technology and data. So I will be talking about how can we use technology, how can we use data, machine learning, to have data-driven policymaking for sustainable urban development. I am currently associated with Lahore University of Management Sciences, where I am working as an associate professor of electrical engineering. I'm also looking after a lab, which is Smart Data Systems and Applications Lab. So outline would be that I will briefly introduce LUMS University and our lab at LUMS. And then I will move towards machine learning for sustainable urban development. And I will be presenting how can we use data to address mobility issues, sprawl in our cities, logistics, urban pollution, and finally urban health. So moving forward, so I'm from Lahore University of Management Sciences. So LUMS is a not-for-profit university. It is based in Lahore, which is the second largest city of Pakistan, with a population of around 15 to 18 million. We don't have the correct census numbers. Yeah, so LUMS is a small-scale university, small to medium scale, and at glance, at any point in time, we have around 5,000 students. We have 42 academic programs. We have around 300 faculty members with PhDs from all good tier universities around the world. By Times Higher Education, we are the 50th best small university globally. And we're also top ranked university in Pakistan by QS ranking. In total, we have 5 schools at LUMS. We have a business school, we have a School of Humanities and Social Sciences. So I am from Sayyid Babarali School of Science and Engineering, and then we have School of Law, and recently we have started School of Education. So in these 5 schools, we offer around 48 programs at BS, MS, and PhD level. So that was a quick overview of LUMS. Moving forward, I will talk about my lab, which is Smart Data Systems and Application Lab. So we established this lab back in 2017 with a vision to harness research, technology, development, and innovation to develop smart solutions for improved quality of life. So in this lab, we have broad expertise in information processing. And if I elaborate on this, so we're working on communication technology, statistical inference, sensor fusion and control, deep learning, machine learning, mathematical optimization, system modeling, and vision and image processing. So we are 3 faculty members in our lab, Dr. Momin, myself, and Dr. Tahir. We have 3 postdoc fellows working with us, Dr. Osama and Dr. Amir, and Dr. Naman is visiting. Currently, we have around 5 PhD students, and we have 4 PhD alumni. In addition to this core team, we have 20 PhD master undergrad students working with us. Since we are doing a lot of development work and research work, so we do have a team of engineers and developers. So these are graduates. So they are working with us. So they work with us for 1 to 2 years, and then they move towards industry, or they move towards graduate programs. Okay, so that was maybe a quick overview of our cumulative indicators of the faculty. So in the last 5 years, we have secured around 320+ million Pakistan rupees funding. We have 175+ publications in the last 5 years, with a cumulative impact factor of 130, 4 patents, and as I said earlier, we have 11 PhD students worked with us in the last 5 years. Okay, so that was an overview of LUMS and Smart Data Systems and Applications Lab. Moving forward towards the topic of today, machine learning for sustainable urban development. Okay, what are we doing here? So we're trying to address a grand challenge, which is Pakistan's runaway urbanization. If we look at some numbers, 65% of Pakistan is already urban if we follow the UN Habitat definition of urbanization. And therefore, we have a grand challenge. And so we're trying to address this runaway urbanization using technology, using data, using machine learning, and so on and so forth. So I will be talking about in more detail the activities we are doing under this project. This project is funded by the Grand Challenge Fund scheme of Higher Education Commission of Pakistan. So around this urban issues, we are looking at 3 intertwined issues, which are urban sprawl, urban mobility, and environment and health. So in developing countries, so we encounter the unplanned infrastructure, we face mobility issues, we don't have infrastructure for waste management, adequate infrastructure for waste management. And then very recently, we are encountering this air pollution issue or smog issues in our cities. So we are working to address all these 3 issues in this project. An overview of our approach. So we want to use technology, we want to use data to have evidence-based decision-making so that we can have sustainable urban communities. Being engineers, being scientists, we mostly focus on this side. We look at technology, we look at data, but so we're trying to address the social issues as well. For example, if we propose some intervention to address female mobility, we need to make sure that the solution we propose, or the policy we propose, or any intervention we propose is acceptable to the society, is inclusive in nature, we take care of equity, and when we collect data, when we disseminate the results, so we are adhering to transparency as well. So this is an overview of our approach. Moving forward, aims and objectives of all of this research work is If I want to define in one line, that is, we want to generate a data, spatial data and temporal data at a scale that has not been seen in Pakistan. And the broad idea is we want to have socially aware and openly accessible technology solutions for urban data collection. We, being engineers, being scientists, we want to develop algorithms and software tool set so that we can carry out urban analytics from the data. We are working with different stakeholders for capacity building of different state institutions and our sectoral partners. And finally, since we are in academia, we focus on knowledge creation. We want to disseminate results in the form of research papers and policy briefs. And we also want to catalyze data-driven decision-making and evidence-based policy design in urban management. This is overall summary of our work. So our work is driven by these 6 verticals, and then we have these 5 horizontals. So working on urban sprawl, urban mobility informatics, smart logistic solutions, how can we have better healthcare facilities in cities, how can we counter air pollution, how can we track air pollution, how can we have better air quality maps, and finally, how can we have better smart waste management in our cities. So across these 6 verticals, we have 5 horizontals. So for each of the vertical, we want to devise a data collection mechanism, data analytics. And once we have the data, we want to mature the algorithm in the form of a software tool set. And finally, from the insights, we want to have data-driven decision-making and policy design. And hopefully by the end of this project, we will have a capacity building in Pakistan. We are working with different stakeholders in Pakistan in this project. Some are state institutions, some are private entities. For example, the PSCA, Punjab Safe City Authority, is looking after the installation of infrastructure, installation of cameras in all major cities of Punjab. And then we have this emergency response services department, which is called 1122 helpline in Pakistan. So they are looking after emergency responses in all major in major urban areas and rural areas in Punjab and KP. Kareem, we all know it's a mobility provider. NTRC is a government department, which is National Transport and Research Center. We are working in collaboration with them so that whatever intervention we propose goes back to in the form of policy. We are working with Chuktai Lab, which is one of the health service providers in Pakistan. We are working with them regarding disease prevalence in urban areas, in rural areas. We are working with JAS, that how can we use their CDR data to find mobility patterns. Lahore Waste Management Company to look after waste management. And M&P is the 2nd largest courier service provider in Pakistan. So we're using their data to find out the logistics, last mile deliveries in urban areas. Okay, so that was a broad overview of the project. And moving forward, I will talk about each of these areas in more detail. That what are we doing? How can we use data technology to address mobility, and so on and so forth. Okay. Broadly, urban mobility, we are looking after origin destination travel times, transit oriented development, the road network, and traffic flows density, because these are the foundations. And once we have this foundation, we can build and we can have many use cases building on these foundations. Okay. So I will talk about OD travel times, road network, and traffic flows density. Okay, what do you mean by OD travel times? OD travel times means how do people move in urban areas, from which area to which area, at what time of the day, what's the frequency of the travel, and so on and so forth. So towards this end, we are working with, we're using Google data, Google API data. We're working with JAS, we're using Kareem data, Kareem has already signed MOU with us. Jazz has already signed NDA with us. And then we are working with National Transport Research Center and Punjab Safe State Authority. So we use all of this data, we fuse the information, we carry out data analytics, and we want to build congestion maps and flows of people moving in cities. I will quickly present one case study. How can we have these OD matrices, OD travel times in urban areas? So we divided Lahore into 25 residential hubs, 8 commercial hubs, and these are distributed across Lahore. And for different times of the day, we use Google API data to find travel time between each pair of origin and destination. So this helps us in formulating a congestion map of Lahore. We can say that this is the outer skirt. We have a ring road here. So we expect better mobility here. And if you move towards downtown, we expect congestion. So simply using Google API data, we can infer the congestion maps. We can have OD travel times for a city. Okay, moving forward, road network is one of the very, very important attribute of any urban study, that how is infrastructure connected, what are the main arteries of city, how the roads are connected, where are primary roads, where are secondary roads, and where are tertiary roads. This is also important if government wants to plan new road infrastructure or we want to improve existing infrastructure. So what are we doing here? So we are using Google imagery, satellite imagery. We are in conjunction with OpenStreetMaps and with some manual labeling. We pass all this data to our machine learning models to build a high resolution, accurate road network of cities. We have developed a pipeline that takes in these data layers as an input and it returns the output. I can quickly show you one demonstration. So this is the imagery we use, satellite imagery, and using the satellite imagery, we can find out the primary roads, secondary roads, and tertiary roads. So this is the road network we have developed. If we compare this road network with what is available, OpenStreetMap road network, our road network has much better spatial resolution. So in OpenStreetMaps, we do have some roads missing and the road network is not accurate. But in comparison, the algorithms which we have developed using machine learning, so we can determine the road network or the graph of the roads in city very, very accurately. Okay, moving forward, traffic flows density is one of the fundamental characteristics used in traffic management, study of traffic flows in the cities to find out the congestion hotspots and so on and so forth. So what are we doing? So we are working in collaboration with Punjab Safe State Authority so that we can use the camera data, camera mounted on the highway on the road network. My apologies. So we use this data to extract traffic insights in real time. So we want to find out what is the traffic vehicle count on roads, how many types of vehicles, how many cars are there, how many trucks are there, and how many rickshaws are there, and how many bikes are there, and so on and so forth. So we have developed a complete pipeline. So we use camera video stream as an input. We process it using a deep learning model. We pass these insights to a database where we learn analytics. And finally, we have a dashboard where we can see the traffic analytics, the road situation in real time. I can simply show you one demonstration. So this is one of the camera deployed in Lahore. So we can detect, using a deep learning model, we can detect the vehicle, we can detect each vehicle, we can even detect motorbikes. And if you see, we can even localize the license plate very, very accurately. And also we can localize driver very accurately. This is simply a deep learning model, which we have trained, which using the data, we collected data, we annotated data, and we simply trained and developed a deep learning model so that we can have these insights. So now we are working in collaboration with Punjab Safe City Authority, and who has deployed cameras, hundreds of cameras around the city of Lahore. And we'll be running these algorithms on their camera streams so that we can have active traffic management, traffic analytics in real time. So this is already tested. We have deployed one node. So the system is almost ready to go. Okay. Moving forward, now I will talk about the urban sprawl. So what are we doing? How can we use machine learning and technology to address urban sprawl, or in fact, to understand urban sprawl? In our cities, we have seen unplanned city growth. We have unprepared city infrastructure. And also, very recently, we have seen unprecedented immigration from rural areas to urban areas. Consequently, we have degraded air quality index in cities, traffic congestion all the time. And then we have these slums in different parts of the city. And consequently, we have unsustainable cities. Okay, how can we use technology and data to make our cities more livable, more sustainable? Or if we even want to study these immigration patterns and how the city has grown over time. We are using remote sensing images again. We're using the digital maps, which are available, and some of the maps we are developing for the regions where we don't have the digital maps available. We pass this through machine learning model, and then we have some use cases here, right? For example, we want to find out where are green spaces in cities, or what's the tree count in our cities, where are built areas, where are unbuilt areas, what is, or we can call it, what is land use classification? How can we find out building footprints using satellite imagery? And this is a new concept, which is transit-oriented development. It corresponds to that there's a need to develop infrastructure where we have better connectivity. For example, in Lahore, we have two mass transit systems. One is Orange Line, one is Metro Line. And so an area where we have an intersection of these two mass transit systems. So there should be more and more development. There should be more better use of land around that area. That is, we refer to it as transit-oriented development. And we're also doing spatio-temporal analysis of urban growth and land surface temperature. I will very briefly talk about what are we doing or what we can do to carry out spatio-temporal analysis of urban growth and land surface temperature. So we want to estimate building construction profiles in 350 societies of Lahore, analyze spatio-temporal urban growth by estimating built-up ratios on 17 different dates. So we get the satellite imagery for 17 different dates. And using satellite imagery, we want to find out where are built and unbuilt areas and how the city has grown over time. We have developed a pipeline using machine learning that can automate the building footprint extraction. And I will also show you the comparison with the ground truth data available. And it is simply showing an error of simply 1% in the calculation of built-up ratios. For example, we use this image as an input to the system. So using machine learning, we can have this probability mask. And when we compare with this ground truth mask, it is reasonably accurate. And this is for one society of Lahore, and this is and one region of the city's blueprint. This is one example. So for example, DHA phase 5 is an area where we have LUMS. In 2010, it looked like something like this, sparsely populated. In 2014, it was it's built up, and in 2020, it's almost fell. So we have simply used satellite imagery at different dates to find out built unbuilt ratio over time. And if for this region, if we see, that's how the buildings are. So on left hand side we have built up counts, and on x-axis we have the dates from 2010 to 2020. So number of building counts has kept on growing with time. So the message here is, using satellite imagery, we can find out built unbuilt regions in cities. We can find green spaces. We can find tree counts. We can find where are hospitals, and this is called point of interest. We can find out schools. We can find out pharmacies. We can find out banks, and so on and so forth. In other use cases, we're using Landsat images, which gives us land surface temperature and also land use and land cover. And we want to find out how the land surface temperature changed over time due to this urbanization. And if we see, so this is Lahore. So in 1998, the average temperature was in this range, and over time, due to urbanization, the average temperature has changed, has grown, in fact, over time. And if we look at, if we correlate this with urbanization, that's how the city has expanded. So it was built up this in 1998, in 2010 it was like this, and in 2021, the city has expanded significantly. And we found that vegetation and water bodies declined over time due to urbanization. Built-up use grew significantly, and more importantly, an average increase of 0.47 degrees per year between 1990 and 2021. Because we don't have enough vegetation, we don't have, this is a land surface temperature. Okay, so next I will talk about urban logistics. So what are we doing to address logistics issues? So logistics, urban logistics refers to mostly provision of services and deliveries in urban areas. Urban logistics, 60% more people living in cities in 2030. So 2.1 billion users going to online shopping by 2021, mostly driven by pandemic. We have 10% annual e-grocery growth and same-day delivery growth. So we have same-day apps coming up, increased 20% to 40%. And this was quoted by World Economic Forum report, the future of last mile ecosystem. So with these trends coming up, e-grocery, growth in e-grocery, growth in online shopping, and this same-day applications. So we have a huge constraints on logistics systems, or what we call last mile logistics. And therefore we'll have significant economic and environmental impact of logistics services on our cities. So what are we doing? So we are working with second largest logistic service delivery provider, which is Muller & Phillips, M&P. We are working with national transportation centers, satellite imagery, digital maps, and Google API. So we use all of this data, and we're working in collaboration with M&P that how can we optimize their last mile logistics distance and delivery time. How should they place their delivery hubs in urban areas so that they can reduce the delivery time, they can reduce the amount of distance they travel every day. We are working collaborations to have real-time route planning. And finally, we are working in collaboration to promote collaborative logistics. So we have these last mile service providers working in a fragmented way. So what we want that they should work in collaboration. They should have the carpooling. They should have more share. I think there is a hand raise. We can perhaps take the question in the end, or if there's any question, I can take it now. Okay. Okay, so when we talk about urban logistics, one of the major issues which we face in Pakistan and we assume in India and also in other developing countries is unstructured addresses. When we write the address for delivery, we don't follow any structured address format. And the consequence of this is we have failed deliveries, we have delivery delays. So how can we address this? To address this, we have developed an AI-based, AI-driven dictionary for address standardization. And we have done this for Lahore for 350 societies. For example, if we give this unstructured address to our dictionary-based model, so this corrects the address in a standard format. And on top of it, it also pinpoints to the reference location. And we have shared this with Mulder and Phillips. And when we use their data to find out the impact of this address correction, if the delivery rider knows the structured address, knows the coordinates of the address for delivery, so on one route, it can save around 9 kilometers. So with unoptimized, the rider is following this path. And if these locations are known prior to the travel, or these locations are known correctly, we can have route optimization so that we can save the distance, the travel by the rider. There's a study in Delhi and where they have shown that if they have structured addresses in Delhi, they can have 40% reduction in travel times in the amount of distance the riders travel to deliver the goods. And this will have a direct impact on environment. This will have a direct impact on the pollution. Okay, we've talked about how can you optimize distance and delivery time. Now I will talk about one case study. How can we use technology and optimization to optimally allocate delivery hubs? For example, this is Lahore, and a logistic company wants to create hub in city of Lahore so that they can serve the different areas of Lahore. So what we propose that we should integrate the data sets we have. We have the population data. We use socioeconomic map to find out the optimal location of hubs. We know where are the commercial hubs in an urban city. I've already shown you we have a road network, that how the infrastructure is connected. And we take into account the operational challenges. And we should take into account the past distribution of deliveries for the planning of placement of delivery hubs in an urban city. And the objective is we want to save time and mileage in the last mile. Okay, I can quickly show you the population and road network. So this is the population map of Lahore. So this is publicly available, I think at a resolution of 1 square kilometer. One of these sources, World Popular Landsat, so they also gives you 100 meter by 100 meter resolution as well. So we know the distribution of population. So this information must be used as a prior to find out optimal location of the delivery centers in urban areas. Similarly, road network, how the roads are connected. So this must also be used to find out the optimal location of hubs. In prior literature, people have used simply population or simply, they have not taken into account the road network while designing or while devising the location of delivery hubs. We should also take into account the distribution of deliveries, that how the deliveries are distributed across city. So where we have a hotspot, the delivery hub should be more closer to the commercial hub, more closer to the hotspot. So this is the data for 4 weeks for MNP deliveries. So we have a distribution of the deliveries, and these are their existing delivery hubs. So they are operating the Lahore region from these 3 hubs, and so these deliveries are being served from each of these hubs. And if we have the provision to relocate these hubs and optimally locate these hubs, so this should be the optimal location of these hubs, so that these deliveries can be served in less amount of time, in less amount by covering less amount of distance, right? And if you compare these two, average distance saving per delivery would be around 1 kilometer. So you assume 26,000 deliveries in 4 weeks times 1, so you save 26,000 kilometers of the rider distance by simply relocating the hubs or by creating more hubs optimally. But noting again, we should take into account the road infrastructure, we should take into account the population, and we should take into account the distribution of deliveries as a prior, on top of the operational challenges being faced by these courier companies. Okay, so we have talked about optimization delivery time, allocation of hubs. So once we have these two in place, we can have real-time route planning. So this is the work we are doing around urban logistics. We are working with logistic companies, we are working with government entities, so that we can have policy devising and finally moving towards collaborative logistics. Okay, moving forward, I will talk about how can we use AI or optimization or machine learning to address urban pollution. So objective is make our cities breathable again. So these days we have a 5th season, which we call a smog season in our urban areas, where the air quality index is much worse than the limit specified by WHO. Okay, what are we doing? We are working in collaboration with Environment Protection Department, EPD, IQ Air. So they have sensors placed in different cities at different places. And then we're also developing some in-house sensors so that we can measure in-house low-cost sensors. So we can measure AQI, we can measure PM2.5, we can measure nitric oxide, we can measure sulfur content, and so on and so forth. So the idea is, how can we fuse all of this information? So some information coming from EPD could be from a reference grade sensor. The measurement from here could be purple sensors, which are low-cost sensors, so they can have some noise. Our sensor can have some noise. So the idea is, how can we combine all of this? How can we fuse all this information to have a better resolution air quality map of our urban areas? Right. Also, we want to, since once we have these sensors available, once we have low-cost sensors, even when we have reference grade sensors, the question is, where should we deploy the sensors so that we can extract the maximum information from the sensor, or we can use the information from the sensor to have a better quality, better resolution air quality map. So what are we doing? We have developed an air quality sensor location suggestion pipeline that once we have, okay, as I said earlier, we have the population density. We know where the population is. We know where the road network is. We can use satellite data as a prior. The satellite data could be MODIS data, which gives you a cover of PM 2.5, a special distribution of PM 2.5. We can use meteorological information, point of interest, that where, I can show you this. We have manually marked these point of interest. So some are industry hotspots, some are commercial hotspots. We have these drainage streams running in urban areas, and then we have some traffic hotspots, right? So all of this information should be taken into account to have a better suggestion for the placement of air quality sensor. And then we have historical AQI data, that what is the distribution of AQI data coming from different sensors, right? So we use all of this information, and we develop a mathematical optimization problem and framework to have a location of a new station in cities. And the idea is entropy minimization based recommendation. So we should have a sensor at a new place so that when it adds information to the existing data, so the information content is maximized or entropy is minimized. And so we have developed this optimization tool that suggests where the sensor should be placed so that we can have better resolution air quality map. Okay, moving forward, I will very briefly talk about urban health. To address health issues or to study health issues in urban cities, we are working in two directions. So one is we're working in collaboration with Geocoding Lab, which is the diagnostic center and health service provider in urban areas, in rural areas. So they have agreed to share data with us. And we want to find out how the diseases are, what is the prevalence of different diseases in different parts of the city, so that we can correlate the information about the diseases with air quality maps, with the population, with the drainage of these streams, and where the waste dumps are, and so on and so forth. Another direction we're working on is how can we have better emergency response services in urban areas? And how can we improve health facilities? And how can we place the emergency response vehicles infrastructure in cities so that response time to the accident site, response time to the crash site or accident site can be minimized. So the idea is we want to optimally allocate EMS resources so that we can maximize the coverage, we can minimize the response time. We are also working with 1122, I mentioned earlier, to carry out accident hotspot analysis. And we're also trying to help them to have real-time route planning. We are working with 1122, we're using GIS data, and we're also using Google APIs data to find out what are the traffic accident hotspots and where should the ambulances be placed. We know where the hospitals are, we know the road infrastructure, we know the population, we know the information about traffic accidents. So combining all of this, we can devise a policy to place these emergency services stations, to place the ambulances so that the response time is minimized and these vehicles can reach the accident site in a minimal amount of time. So I can quickly show you the weekly distribution of road traffic accidents across Lahore from July to December. So we get the data from 1122, and this is the distribution of road accidents at different parts of a city. And you can see there are hotspots. So for example, this hotspot is always here. So there's a big hotspot here. So this suggests, so potentially there is a need to improve the infrastructure in this region, or perhaps there is a need to add more more resources there so that this hotspot can be addressed. If we look at some more information, so we have we identified five severe road traffic crashes hotspot. So at this place, we have a lot of accidents. At this place, a lot of accidents. And now we are working in collaboration with 112 and government authorities to do some manual surveys. So I want to deploy the manual, we want to conduct manual surveys here so that we can identify the actual cause of these road traffic crashes hotspots. So that was all from my side. So we have talked about urban sprawl, urban mobility informatics, urban pollution, urban health, and urban logistics. And I've tried to explain you the use cases. How can we use technology? How can we use data, machine learning to study urban issues, and what can we do to have data-driven policy making? If you have any suggestions, any comments, any questions, you can ask here, and perhaps you can feel free to write to us.
Thank you, Dr. Zubair. Okay, to the participants, please mention your questions in the chat, or if you raise your hand, we can unmute you.
I think Naveen has asked a question.
Okay, we have. Okay, go on, Mr. Naveen.
Naveen is muted, perhaps.
Mr. Zan asked a question in the chat. He's asked about what about noise pollution?
Very, very important question, Zan. The sensors we are developing for in-house, we have deployed this small microphone here so that we can sense the noise as well. So the sensors we will be deploying around cities, so we will be recording the noise level in dBs, in decibels. Indeed, that's a problem. I think very good point.
So Mr. Naveen asked, I don't know if you can answer this, that where did you collect the data from? Because it is not available online. Did you collect it manually?
So we are working with our sectoral partners. We are working in collaboration with 112. So they have shared the data with us. We are working with MNP Logistics. So they have shared their data with us. I understand it takes a lot of time to convince both government organizations and private organizations, so to the point where they are open to sharing the data. So, and we do have plans, for example, for the 112 data, we have already taken their consent that we will make this data public so that other researchers can derive more insights from the data. And similarly, we are signing MOUs and NDAs. So the road network, which we have developed, we will share, we will make the road network publicly available so that people can use it. Yeah, so data is coming from different stakeholders, from different government institutions, from different private institutions. And the data which we are developing, which we are generating, so we will make the data publicly available very shortly.
Okay, so Ms. Zainab has asked, this program is only for Lahore, not for other cities?
No, so we are moving towards Peshawar. So right after Eid, so we will be visiting Peshawar, and we will have a meeting lined up with Peshawar government. And for example, one of the major issues in Peshawar is mobility, the traffic congestion. If someone is from Peshawar, they know the University Road is a major hotspot. So we are trying to build a collaboration with KP government, Peshawar government, so that we can study the traffic dynamics of the University Road. What is the origin of the traffic? And furthermore, we are building these tools. We are doing this study for Lahore. Nevertheless, all of this can be applicable to Karachi and to any other major urban city outside Pakistan as well, assuming we have the same dynamics. We have same problems all around.
So we have one person from Mohammed Arsalan. He has asked, can you do research in agriculture aspect, like prevalence of diseases or in a specific region, or insects that transmit diseases?
So we have expertise in information processing. We would like to do, we can do a lot of things, but given the bandwidth, we cannot do everything. But if the government is willing to, or if we have a participant here who is willing to share data with us, we can get some insights. By the way, we have an agricultural lab here at LUMS. We have a water informatics center here, WIT, which is being looked after by Dr. Abubakar. So they do a lot of stuff on agriculture, crop classification, and so on and so forth. Naveen is asking which are the main algorithms for traffic density detection. So Naveen, we're using deep learning based approaches. Deep learning, deep sort, which is machine learning driven. So we use the data, we train the models, we tweak the models, we train the parameters, we fine tune the parameters so that we can have detection of the vehicles. And then once we have the vehicles detected, we use post-processing to extract more insights. So I think Dr. Sama is asking, how can study climate change this data? How can calculate data error? Yeah. So when we talk about climate change and we talk about air pollution, there's a debate about the authenticity of the numbers. We often hear that the data is not reliable, and therefore we are trying to devise a policy. We would love to have the policy that any new society in Pakistan should have one reference grade sensor. So if this policy can be formulated, so that will be generating reliable data, and which can be used to have better quality, better air quality maps. So the answer is we can have reference grade sensors, and these reference grade sensors are costly, but they must be installed.
Okay, we have one from Abdul Samad.
Yeah.
Do you have any issues in acquiring data from private and public sources?
Yeah, so when it comes to data, so there are two types of companies or organizations. So the one who knows that there's a value in the data, they don't share, right? And then we have the organization, and they know that the data does not have any, may not have any value, and then they don't share the data, right? And it takes a lot of time to negotiate with government departments, with private departments, and convince them that they should share the data. And then at times we'll have to negotiate as well. For example, with Punjab Safe City Authority, we understand that they are getting the data from cameras installed at almost every intersection of Lahore. We understand that they cannot share the video feed with us. and this is this is indeed correct. By law, they're not allowed to share their video stream with us. But what they have agreed is that we can go to their premises, we can run our algorithms on the video streams, and the insights we get from the video stream, that is something which we can use. Right? And similarly, for example, with 1122, and they were very open on sharing the data, and perhaps they have agreed, in fact, they have agreed that we should share their data with publicly so that other researchers can also use it. Yeah, so you have to negotiate, and yeah.
I think those are all the questions.
If there are any other questions, and if someone wants to collaborate, if you have any suggestions, any comments, any ideas, please feel free to write to us.
Sure. There's one more from Abdul Samad. He says, do you feel there is a need for a national data policy in Pakistan?
Yeah, there is a need of many policies in Pakistan. Perhaps national data is the one. And for formulating such policy, we should have different stakeholders. We should have all stakeholders agree to the policy so that we can have a more comprehensive, inclusive, and transparent policy looking after data protocols, data handling, data security in Pakistan. Yes.
So Dr. Samia Taslim has asked, can this technology used to calculate carbon footprint or carbon count in the air?
Yeah, so once we have these, for vehicle emissions, yes, if we have an estimate of the vehicle density and the traffic, that is something which you can correlate. For example, for this logistics study I've shown you, so if we are reducing the amount of distance traveled by last mile delivery riders, that will have a direct impact on reducing carbon footprint. And Dr. Shamila is asking, can this technology used for distribution of primary and secondary pollutants? We can add more sensors, but currently we're looking after, I think, NO, sulfates, and PM2.5 and PM10, and ozone as well.
Okay, I think those are all the questions. If there are any more questions, just email them to me and I will pass them on to Dr. Zubair. So just to mention that this webinar is being recorded, so it will be available later on the Comstech YouTube channel. So if everyone wants to revisit the lecture, they can do so. So with that, I would like to thank once again Dr. Zubair for taking out such precious time and delivering such an important lecture for us. Thank you so much, sir. And
thank you very much. Thank you for
the lecture with you.
I would like to thank the participants for their patience and for being for the last 1 hour. Thank you.